Default route. Default route. You see, when we write static route, on the stub routers, we used to write default route. This is the command that we use always to write default route. A statically configured default route. We configure saying IP route, any network, any subnet mask, go to this next hop, or go via this interface. And this configuration that you are doing is local to that router. Now, this default route, which we write locally, statically, you can make the dynamic routing protocol to advertise. All right. That you can type this command, redistribute static, so that this static route can be redistributed to all the EIGRP routers, so that you no need to go and configure default route on every router inside the autonomous system. I think there is a need for a nice picture for this. Let me draw a picture for you. You see, I have an autonomous system. I have an autonomous system called EIGRP 100. Inside this, I have a lot of routers. Right. We have a big autonomous system. Now, here is the internet. Here is the internet. So what do? We write a default route in this router, IP route, any network, any subnet mask, go via serial 0. Correct? This is how we write. And this one, if you write only on this router, is that sufficient? No. You need to tell to every router that if you want to go to unknown destinations, you go here. And then here you have to say go here. And then here you need to say go here. And then you need to say here, go here. And then rest this will take care. Again, you have to go here and say go here. Or go here. Go here. Go here. Go here. Go here. When I say go here, I am reminded with one language called Golang. Anyone knows this language? Golang? I think Golang is Golang. Anyone knows this language? Golang? Have you heard about this language? Okay. This is one of the programming language which is going to gain popular very soon. But this is there for many years, almost like 8 years. When Google started using this one for fast processing, it's more faster than Python and any other programming language. Faster than Java, faster than Python. I have started learning this now. It's very useful for developers. Golang. There is again, another binding called DPDK. So people with the knowledge of Golang and DPDK can develop their own operating systems for routers, switches, firewalls. So that's what I'm keeping as my next target. I started learning Golang. Now, these routers, you cannot go every router and write static route pointing towards the edge route. This is a very tedious job. So what we can do is, we can take this default route, which we statically manually wrote on the edge router. We can take it and redistribute it inside EIGRP. That's one option. We can take this static route and we say redistribute static, and we give some metric value. I'll do and show you. So now, without you writing a default route on these routers, it gets distributed and updated into the routing table. So all this router 1, router 2, router 3, router 4, router 5, from the edge router, the default route gets advertised using EIGRP. See how easy it is? You don't need to go and write a default route pointing towards edge route. But there is also another option if you want. So that is one of the options. You can redistribute. What is the other option? In any classful network residing in a local routing table can become a default candidate when used with IP default network configuration command. The command attaches the exterior flag to any classful EIGRP route, thus making it candidate for default route. But again, this is not good. Why? Everywhere, what do you see? Do we have classful network in our production? No, most of the time it is classless. Okay, what does this actually tells you? See, in your topology, if you have only classful networks, then you no need to redistribute. You just go to this router and use the command IP default network command and define the ISP's network as default network. Let's say ISP is 20005 slash 20000. Sorry, 20000. And say define the network in the global mode. See, you're not doing this under EIGRP. In the global mode, the global configuration mode, you define this network as a default network and then go under EIGRP, use the network command and advertise this. Oh no. And advertise 20. See, because it has already been defined as a default network, EIGRP will also advertise with D star. D star means what? That is the network responsible for all unknown destination. So to go to 20, it needs to go to edge. Automatically, dual algorithm, EIGRP's routes are seen as what? D, no? In the routing table, EIGRP routes are not seen as E. Does it show E, elephant? No. It shows D, donkey, dual. Yep. So all the routers will have D star. But this is good only for class 2 network. So you should have enabled auto summarization. You should enable auto summarization on all routers. That's again not good. Okay, this is best. This is best. This is just an optional one. Okay. Did you understand this? Now, this is the output on the edge router. On the edge router, we have statically defined default route pointing towards the gateway. This is the IP address of the ISP. And inside EIGRP, we say router EIGRP1 redistribute static. This is not correct. I don't know why they have not mentioned the metric. Whenever you redistribute, you should mention the metric. For the default route, what is the metric in EIGRP? Let's say bandwidth as 1000 kilobits and load 1, delay 1, reliability MTU. You have to mention this, otherwise it won't redistribute. You see, let me show you in the lab. Now you please understand this topology. I'll show you both. There are two options, right? First one is redistribution option. Second one is IP default network. I'm going to show you the second one first because it is already configured in this. I know in my previous class, sometime long back when I was teaching this, in that previous class, I showed default network. This is our ISP 22.5.244. See, the default network command is good for only class 4. But I have here classless. But what I did is I enabled auto summarization to make this class 2. That's why not recommended. Better go for the first option, redistribution. You see, watch carefully. On R3, show IP route. I have a default route. Do you see that? I have it. Now, I have also defined it as default network. See, show run section IP route. Do I have a default route written? No. But how did I get this? It is because I have defined this particular gateway and this particular network as a default network. I just wrote one static route and I have defined that as a default network. Let me show you that also. You see, I have written one static route. I told you it is a classful environment only. This one is good. So I wrote a class, though it is 24/24. I wrote a classful static route and I have defined the 20 network, which is of ISP, as a default network. And then what I did, when you do this, you will get this automatically. All right. And then what I did is, I advertised that 20 network. under EIGRP. And because it is already defined as a default network, now if you go to router 4, and check the routing table, show IP route. Let me go to router 2. Show IP protocol. This is still not out of message enabled. Okay, something is missing. So meanwhile, let me repeat what we have done. We have a static classful route to the ISP, and we have defined that ISP network as default. When you do this, this is coming because you wrote static route, and the star is coming because you defined it as default network, and this will also automatically come. And then when you advertise that in EIGRP, now EIGRP will take responsibility to advertise it as a default network. So I'm expecting, not seeing. It's all because of the classless environment I'm having. So it won't come actually. I need to change the networks to make it classful. That's why it was very clearly mentioned, if you only have classful, then you do this. Don't waste time in this classless with this default command. Make all classful, then it will work. All classful networks, not subnetted networks. Now we are going to this one. This is better. We already have a static route which I'm going to remove. I'm going to remove all of them. No. This I don't want. No. This. I remove this. And now what I'm going to do, IP route, any network, any subnet mask, send it to 20.2.5.254. I've written the default route. Now I'll go on the router EIGRP. Autonomous system number is 1. You see, EIGRP 1. Router EIGRP 1. And I'm going to say redistribute the static. If you hit enter, it will not redistribute. It will not redistribute. You have to put the metric. Show IP route. Oh, great. Sorry, it redistributes. I don't know what metric it is taking. But it is always good to have a metric. Okay, so the presentation is right. It works. Usually in all distance vector protocol, we need to specify metric. You see D star external. So you don't need to go to each and every router writing a default route. Show IP route. EIGR. I have a default route. So I can ping these networks which I don't have a route here. Do I have route for 115? But I can ping it. Why the ping is not happening? Maybe R5 do not know about this network. In the real world, we will do natting, so ping will happen. Now, what I'm going to do is I'm going to write a back path, reply path, or reverse path. Let me check the routing table first. Show IP route. Do I have the route? Yes, I do have it. I do have 155. Oh, no, 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 no. It's 155, not 115. I was pinging 115. That doesn't exist. Okay, now let me go to router 1 again and try pinging the right one. 155. So this ping is happening. The reply is coming because I saw here a return path has been given already by me. This is what I was about to write, but I see that already. Though router 1 do not know the route in the routing table, you are able to ping because of that default route advertised to you by the border router R3 via EIGRP. Is this clear, everyone? We did on redistribution, that's it. Redistribute static. We need to write a default route pointing towards the ISP and then redistribute it. That's it. Every router inside the autonomous system will be able to reach the external network. All right, moving on to the next. Load balancing with EIGRP. You see, all routing protocol will support equal cost load balancing. What does that mean by equal cost load balancing? When you have equal metric via multiple paths to reach a destination, we call it as equal cost paths. EIGRP can do load sharing, load balancing across multiple paths to that destination. Now, how many paths it can use? By default, it can use up to 4 equal cost path, equal metric path. But if you wish to increase them to big numbers, like 6 or 8, you may use this command maximum path. So this is going to help you to increase the number from 4 to any big number, or you can also reduce it to 2 or 3 if you want. So not only for equal cost path, if you enable unequal cost path, even for that, this number of paths that you define will be applicable. Let's say you enable the variance so that you can use some unequal cost path. Have you seen that lab, variance, unequal cost path lab? Okay, thank you. So that unequal cost path, how many paths? If I have in topology table 10 paths to a destination with unequal, will all 10 be used? No. Any 4 will be used. But can I make it to use 8? Yes, use this max path. So this command is not only for equal cost path, it is also for unequal cost. In general, for load balancing, whether it is equal or unequal, doesn't matter. This command is common. EIGRP can distribute traffics over multiple links leading to same destination so that you can reach faster, because you're going to use multiple links, then more bandwidth, more traffic at the same time can go and get delivered. When a packet is process switched, load balancing over equal cost path occurs per packet. When the packet is fast switched, load balancing over equal metric path occurs on per destination basis. Okay. When packet is going to go through CEF, Cisco Express Forwarding Chain, both per packet, per destination load balancing happens. Load balancing occurs, load balancing over unequal metric link is disabled by default. Only feasible successor path can be included in the EIGRP load balancing to ensure the topology stays loop free. You know the stories, but I would like to explain the first 3 points. I'll explain all 5 of them. See, in the beginning, we were doing this process switched. Meaning every packet should go through the routing table one by one, finding the best path for the exit one by one. In that case, if you have multiple paths for load balancing, the router will put first packet in this one, second packet in this one, third packet in this one. It is per packet basis because in the routing table, packet is also processed one by one. One packet goes to the routing table says go this way. Another packet goes go away this way. Per packet basis. Old style. We don't have that bad routers now. What is fast switching? Only the first packet will go to the routing table to find the exit path. Once the destination path is found as multiple paths, to that destination, all available paths will be used. But first packet will be going through the routing table. After going to the routing table to go to the destination, I see path 1, path 2, path 3 in the routing table. That information will be downloaded to a buffer. In layer 2 level. So now from the second packet onwards, it will just refer the buffer and does equal cost load balancing per destination basis. CEF is much more advanced. Here every packet should go through the routing table process. Here first packet should go through it. Here no packet goes through the routing table. No packet. Why? Before your packet comes. In layer 2, there is a table called CEF table with all the routing information. I repeat, all the routing information in layer 2 level with the next hop, with the exit interface is seen in the CEF table. So you don't need to now go to the routing table to know the route. So now because the CEF table already knows for each destination all available paths, it can do both per packet basis. First packet go via first path, second packet go via second path, third packet, or for that destination go this way, for the next destination go this way, for the next destination go this way. You can do both, that is what it means. It supports both. Currently we have this one, In all routers of Cisco, not only in Cisco, in another vendor, we call it as fib table. In every vendor, this fib table is present. In Cisco, we call it as CEF, Cisco Express Forwarding. In other vendors, we call it as fib, forwarding information base. Yeah. CEF is enabled by default. So currently we have both per packet and per destination load balancing. Load balancing over unequal cost path is not enabled by default. We all know that we have to increase the variance to enable it. So we need to make sure that there is a backup path, feasible successor path in the topology table so that when you enable variance, unequal cost load balancing can happen. For both unequal cost load balancing and equal cost load balancing, the topology table should have more than one path. Only then it can be used in the routing table. Remember feasibility condition and all. Let's go next. Okay, here we go. Headquarters has got 3 paths to reach branch office. The bottom link is 1 megabits per second. The above two links are 4 megabits bits per second. So what do you think? Headquarters will use to reach this network both this path and this path simultaneously, parallelly, which is enabled by default. We call it as equal cost load balancing. So it has got multiple paths to reach this destination. You see, that's what it shows. You have path via router 2.2 and 1.2. This is 1.2, 1.2 gateway. This is 2.2 gateway. Headquarters have got 2 paths to this destination because of the same FD value. But in the topology table, you also have a third path. But the metric is too high, you see. This is the FD value. These two FDs are lower and same. That's why you see these two in the routing table. This one is a qualified feasible successor, but it cannot be used in the routing table because by default, unequal is not supported, not enabled. It is supported, not enabled. If you want to enable it, you need to increase the variance. If I put variance 2, then this number will be multiplied by 2. And I will get an answer. Will that be greater than this? No means then you need to put 3 and multiply. Only then this will be used. Even after multiplying by 3, if it is not sufficient, if you are not getting this number, then multiply by 4. The variance should be 4. Let's do one thing. Calculate. Four zero nine six 0, 0. If I multiply by 2, which means I'm putting variance as 2, I get this number. Is that sufficient? No, not sufficient. I have 7 digit. So I'll change this to I'll change this to 3. 409600 multiplied by 3. Even now I cannot. Let me do one thing. 2297856 divided by 409600. Okay, I need to multiply it by 6. I need to put variance 6 if I want this root also to be considered in this routing table here. 6. Look at this page. That is what we did. That's what we calculated. This is how you enable unequal cost load balancing, unequal metric load balancing. So you're telling that any route whose metric is lesser than that multiplier value. There's the calculation. No calculation. Fine. So you're saying all the paths which is having metric lesser than this multiplied value can be used. Now you see, this also has come into the routing table. Now, what about the traffic? Will it be equally shared? No. According to the capacity, this has got more capacity than this. See, less bandwidth, big number. Less bandwidth, big number. More bandwidth, small number. So these two are more bandwidth links. So according to the capacity, the load balance will happen. You don't need to worry. If there is 1,000 packet to send, it may send 200 packet in this. 400 in this, 400 in this. I'm just telling rough and for understanding. According to the capacity. You see, we have the default number of path, max path. But variance we have increased. The default variance is 1. We have increased to 6. Are you clear with this load balancing story?